Hello and welcome to OpenGL Oversimplified. If you've ever had any questions about an OpenGL function, this is the bit where we're really going to dig into it. So today I want to look at the depth, not the depth stencil. It's involved in the depth stencil, but I want to have a look at the stencil buffer. So you've probably seen a bunch of times that we have a color buffer and a depth buffer, but that's often called a depth stencil buffer. And the reason for that is that if we've got 32 bits in which to store some info, it's pretty economical to pack this together. So we'll have 24 bits representing the depth value of our pixel, our fragment, and we'll have 1 byte, 8 bits representing the stencil. Okay, so here is how the programming model works, roughly. We're going to have some destination fragment that we're writing to, and that destination fragment is going to have a bunch of info, including its stencil value. And at the moment, we've got some source fragment, which is, coming in, we're about to do something, and we need to decide whether to pass that source fragment or not. And in order to do that, we're going to need to perform some sort of test. So we have some sort of test, and this test is based on the current value in that stencil buffer, right? If we're doing a depth test, for instance, then this source fragment that's coming in is going to have some depth info. We can compare the depth here to the depth here. But with a stencil buffer, stencil test, we're just looking. It's not possible for this thing to have any stencil info. We're just looking at the stencil info. Well, I shouldn't say that. There's probably some esoteric case. But anyway, so basically what we do is we apply some sort of stencil function, which will either pass or fail. And the arguments to that are the value in the stencil buffer and some sort of reference value that we're comparing to. It could be like, is the value in the stencil buffer equal to this? Is it greater than this? Is it less than this? And so on. And in addition, because stencil buffers are somewhat flexible, we can also do a bitwise AND before putting these arguments into the test. We can, I'll say, test mask. You know what I'm saying here. So there's a mask, a single number for both of these, which is applied to both arguments. Okay, and then based on this, there's a number of operations number of outcomes we can get. First of all, we could get that the stencil test passes. Then we could get a little more specific. We could get the case that the stencil test passes fails. What am I thinking? So we could have stencil failing, stencil passing, depth failing, or both of them passing. We may want to take different operations depending on what the outcome is. And by the way, you probably noticed that in the case where the stencil test fails, there's not an option for the depth test. This is because, as far as I can see, the stencil test appears to be performed before the depth test. And if the stencil test fails, then the depth test is not performed. Anyway, so based on each of these, there's going to be some sort of operation which we've chosen to perform. We could be like incrementing the value in the stencil. We could be decrementing the value in the stencil. We could be keeping the current value. We could be incrementing and then wrapping around if we reach the maximum value. So our stencil value goes up and up and up. When it reaches 255, it goes down to 0. All sorts of things. That's specified by us. But the really important thing to note here is that when we get here and we want to change the value, we'll have some sort of operation. Again, it could be adding, subtracting, all these things. But that operation chooses a new value which is going to go in the stencil, and that is then bitwise ANDed with a right mask. So I guess the elephant in the room is, what's the purpose of all these bitwise masks? Is it just to confuse learners? Well, the idea is that a stencil test and a stencil buffer and all this stuff should be somewhat flexible, and it should be used, or it can be used, to apply various effects. And we could have different sorts of effects. We've got 8 bits here. We may want to apply a different stencil test for a different bit, in which case we would use a different mask to just examine a certain bit of the stencil buffer. And like if we've got, off the top of my head, I don't know, some outlining effect and some decal effect, I probably don't want the outcome of the outline to affect the status of the decal, if that makes sense. Anyway, so with that little overview, let's jump in and have a look at a practical example. Okay, so here we are. You may remember from one of my previous videos that I've sort of been tinkering around with a hobby project. It's a little framework, and a test case for this is I want to draw a bunch of sprites to the screen at random positions and things. So as a benchmark, let's say we have 1024 sprites. Let's do this in Pygame. It takes a second. We're getting, what, 24 frames per second? Okay. And now let's pop over to my OpenGL accelerated version and have a look at it. Actually, first up, let me just... This might be going in the deep end a little bit, but side note, if you are running i3 window manager, and there we go, and you're getting with GLFW a situation where it's popping the window off to the side and doing weird scaling with it and stuff, you can actually disable that by setting the setting the resizability to false. And that actually bakes in a bunch of constants that i3 window manager uses, and that actually lets it pop out. There we have it. Okay, so we're running at 9 frames per second, and that's really bad. So this is not so evident in higher end GPUs because those operations are a little faster to do. But the issue, or one of the issues, is the way I'm drawing these sprites. So they're not 3D, they are picking random sizes, but they're drawing back to front, and this is like the maximum possible amount of overdraw. Now, if I were to reverse that, I'd be drawing front to back, and then I want some sort of test to check whether a fragment has been drawn to before. Now you might be thinking, hey, this is a depth test. And yes, it is, but a depth test involves floating point comparison. It's actually, you know what, it might not be that bad, but I just want to have a simpler sort of depth test, which is when I write a fragment to the screen, I simply write out a value of 1 or something. I write out some info, and then when I come to draw a fragment, if that fragment has already been drawn to, I just want a really simple like integer test to say, hey, it's not going to work. So for this, I'm going to, why is that not? There we go. It's super slow. I'm going to do stencil tests. So the first thing I'm going to do is I'm going to enable stencil testing. Stencil tests, awesome. The next thing I'm going to do is I'm going to specify the stencil mask that I'll apply upon writing back to the stencil buffer. So we'll go GL, mask. And we actually doesn't matter, because I really just care if the number is 0 or 1. So what I'll do is I'll just apply a mask of 1, and just so this makes sense in hexadecimal, that's like that. So I really just care about that last least significant bit, whether it's 0 or 1. And then what I'll do is I'll specify my stencil function, and this is my test. So my test will be whether the fragment is equal to 0. Upon beginning the frame, the stencil buffer gets initialized to all zeros. So if it's 0, nothing's been written. So I'll go GL equal. This is similar to the depth test. So it's, equal, less than, greater than, never, always, all of those. Okay, so I want to see if it's equal to 0. And because I just care about that last least significant bit, I'll mask everything off. Which, by the way, the default value for this is specified anyway, so it's not like we can set a simpler mask and it doesn't speed things up. So then the last thing is I'm going to set my, there we go, my stencil operation. Now, in the case where the stencil fails, I'm simply going to keep the current value. So what this means is we go, okay, I'm going to draw a pixel. The stencil at that fragment that I'm drawing to has been set to 1 because something's been drawn there already. Okay, so the stencil test fails, so we'll just keep the current value, and so that stencil info will stay at 1 for that fragment. In the case that, well, these next two are going to be the same because I'm not doing a depth test. So in the case that the stencil test passes, I want to increment the stencil value. So I'll go GL increment, and you can see here we have increment, increment wrap. We can also go decrement and all of that, but I'll go there, and then the same. Okay. Right, so I think all I need to do here is when I start drawing, I clear my color buffer. I'm also going to clear my stencil buffer. And I think, yeah, there we have it. Cool. So again, for reference, if I were doing this in Pygame, I'm getting 24 frames per second. And now if I do this in my renderer, fingers crossed, hey, I've gone from 9 frames per second to 55 frames per second. And looking here, this looks stable. I can't see any weird like artifacts. So that looks good. The only, of course, it's going to look the same right now because this is a random test case, but the only other thing I would need to do is reverse the order. So it's a pretty reasonable question to ask, why don't we just use a stencil buffer for all depth testing? And the answer is this is a very special case where ahead of time I have a guaranteed draw order. So it may be expensive to order the objects before testing, and it might be easier just to throw it at a depth buffer. The GPU has the capability for that. Anyway, so I hope you enjoyed that. This has just been a little talk about stencil buffers. And yeah, have a good one. Bye. Hello. I just want to give a quick little shout out and thank you to all of my channel supporters. I'm community fund. That's a tough word. I'm community funded. It's how I keep the lights running. Not really, but it's how I... So I really appreciate any and all support. If you can't support financially or don't want to, look, that's totally fine. It's not expected. It's sort of a premium subscription thing. In that case, the best thing you can do to support the channel is to comment, let me know what you're liking, what you're not liking, I know I do a bunch of things, but I am trying to make the best educational content that I can. So, big thank you to Antonin Carret, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Jason Coleman, Mathieu Derick, Moim, Shreyar, and Maxim Shukim. Thank you so much, my dudes. It really does mean a lot. Yeah, cheers. Gonna get hit. Have a good one, and I'll see you again soon. Bye.